What's up, everybody? Welcome back to another live stream from Scalar Learning. And sorry for the fact that I haven't put out a video in almost a week. I think a week last Friday was when I put out the last one. And so it's been a while for a live stream, but I've been out of town at spring break right now, and that's the reason for some of these delays. But we're getting right back into it today, back on track with the SAT. By the way, I am officially registered for the May 4th SAT, which I'm very excited about. So I'll be doing an entire series leading up to that, getting you guys ready for this May 4th, 2019 SAT. And then, of course, I'm going to do a whole video on what to do the morning of and take you through that whole process as I take it, and then I'll do a score release as always. Anyways, as we're continuing today with more topics straight from the source from Khan Academy, we are tackling key features of graphs. So without further ado, here we go. And as always, I'm doing these problems for the first time. I haven't seen them before, and that's part of the fun. And we're going to solve it in real time so you can get an idea on how to really, truly, authentically tackle these problems. So let's do it. The graph at the left in the LF plane relates the lengths in meter. You know what? Let's do this. Let's actually take a screenshot. Hold on here. You know what? Let's zoom out. And let's go to regular size. See if I can get the whole thing in here. I know this gets a little small and people have complained. Viewers have complained, so I try to keep it as big as possible, but there we go. All right, let's zoom back in. Okay. And then we're going to put the graph here. So the graph at the left, now to be the right, relates the length in meters of a particular thickness of a guitar. This is the length in meters to the frequency, F, in hertz. So here's the frequency. By what factor does the frequency decrease between string lengths 0.5 and 0.6? Repeating, it looks like. That's tricky. So 0.5. Oh, they map these points out. Here we go. So it goes by what factor does the frequency decrease? It decreases by 0.75, I would have to say. Because we multiply there, I think they're talking about a scale factor here, which is kind of funny, but it decreases. They're not talking about slope, are they? Hold on, I got to think about this for a second. Because if it's slope, it's 100 over 0.16. No, that's crazy because that's huge. Yeah, no, they're talking about just scale factor. So it's basically like what times the 400 will I get to, will I have to multiply the 400 by to get 300? And that would be 0.75 or 3/4, because 3/4 of 400 gives me 300. So it should be 0.75, I believe. Let's see if that's correct. Yeah, there we go. So that's it. Just trying to find that scale factor. And again, scale factor is a number you multiply by something to scale it down to get to the next value. Based on the bone mass to body mass ratio of modern reptiles, paleontologists can use this blah, 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 predict its rate of growth, R, kilograms per year at the age A in years. And use fossils to predict its rate of growth. Cool. Rate of growth has I'm waiting for a formula. Rate of growth has a minimum of 50 kilograms per year when the dinosaur's age is less than 1. So it'd be like 50 when it's like at, I don't know, I'm making up like a little graph here. And then, and greater than 29. So here would be the other thing. So it's back to this 50. Additionally, the rate of growth reaches a maximum of 600 kilograms per year at 16. Somewhere in the middle here, I guess. And then we're talking about a much higher value of 600. All I can say from this information is it could look like this. But it also could look like this, whatever. I'm just assuming that since this is a biological phenomenon, we're talking about years on the bottom, right? And then this growth rate on the top. And that makes sense to me, something like this. And that kind of looks like what I just drew, actually. 29, so this is 200, 100. The problem is that this looks like it goes to 0, almost hitting 0. Like 50 is up here. You see what I'm saying? And that's not what I wrote. It's like the 50, and the minimum. It has a minimum of 50 kilograms for you, so it shouldn't go below 50. That's my issue with A, but I like the maximum at 616, so otherwise that looks good. This doesn't make any sense. This one looks like this one doesn't make any sense because it doesn't say here up to 29 it's drop back down. So here we go. This is it. And remember I said this value up here is about 100. That's about 50, and that's what we're noticing. And that's the minimum. It shouldn't go below 50, and it's hitting that max right there. So there's your graph. Now, do you have to draw it out in the way that I did? And I'm not saying you have to make a full sketch before you actually look. In fact, you shouldn't do that. But you see the analysis and you see the fact that I'm like, okay, well, I'm identifying my key points, my min and my max. And I'm recognizing where it's going to come to the max and back to the min, etc. And then you can use that to quickly figure, you know, it's immediately between A or C. And then A has that violation of the minimum, and that's the problem. All right, next. A retail store is purchasing end coats from a specialty coat designer. The cost per coat, C, in dollars reaches a minimum. Okay, so again, this is a graph. Let me try and write this out. Okay. So one coat, it reaches a max of 300. And then when 125 coats are purchased, it reaches a minimum of so this is the maximum and this is the minimum. It doesn't say what the minimum is here, so it's X. And then here's my graph. Something like this. So this is coats and this is cost per coat, C. Let's not make it coats because they're both C. Let's say number of coats. Represent the cost per coat when purchasing end coats. The minimum at 125. This seems like it makes sense. It's a maximum when one coat is purchased, which is like about this, a minimum right here. And then I guess the cost per coat could start rising after that. Okay, let's see what else. This doesn't make sense. It's putting the maximum at 125. So I'm going to eliminate some of these guys like this. A, B, C, D. So B is out. This looks okay, except for it said that 300 is the maximum. So we can't have a maximum occurring over here because 300 at one coat is the max. So C is also gone. Now it's down to A or D. This looks okay, except for the minimum is occurring at 75, not 125. So I can immediately say that it has to be A. I didn't know it would go back up, but they're saying it does go back up, and that's okay. It can go back up, and that's it. Next. Okay, let's again take a screenshot of this so we can look at it over here. Oh. All right, here we go. Now notice these are just all about analysis. You're not even crunching any numbers or have to know anything. All the information, these questions are really cool because all the information is right there. You just got to be able to interpret that graph. And the best way to do that is just practice, practice, practice. Get comfortable looking at, quickly looking through the X values, the Y values, and understanding the correlations and the relationships. That's all graphs are. It's just like equations, relationships. The graph in the XC plane at left, this is my C. My X shows a long run average cost for a company producing appliances. C is the average, right here, average production cost. when the total output is X appliances per day. Okay. So you're doing 1,000 per day. Your average cost is 35 per. Sure. Okay. How many appliances should the company produce per day to minimize average production costs? It's right here. This is the minimum, 600. So, what? Wait, why is this not there? Oh, there we go. I think that's it. All right, I need to make sure this is not too simple. To minimize average, when the total output is X appliances, is the average production cost per appliance. Average production cost. Hold on. Average production cost. Wait a minute. I feel like this is too easy. See how they kind of changed the language and they're like, C is the average production cost per appliance. And then they say, how many appliances should the company produce to minimize average production cost, not average production cost per appliance. It'd be too hard if what I'm saying is true. Like, what I'm thinking is, I need to multiply 600 times like 27.5 and see, but then this one's clearly no, that doesn't make any sense. I'm trying to say then, okay, so what's the total cost? But when you make 0 and you got average of whatever, then 0 would be the answer. That doesn't make any sense. I think it's got to be 600. I can't, unless I'm misinterpreting this graph. Yeah. Okay. So that was just a really straightforward one. I sometimes catch myself when it feels so easy and I need to, just to reevaluate for a second. Okay. Next, a computer clock changes its voltage V over time, T nanoseconds, in order to control the blah, blah, blah. The clock starts with a voltage of 0. So it looks like I can even see from this graph, it's voltage on the Y and T on the X, which usually we have. Time is always on the X. Starts with a voltage of 0, okay, then increases to 0.1, something like this. It stays at 0.1 for 10 nanoseconds. So this could be like, I don't know, 1 to 11 or something. And finally decreases to 0. All right, that should be, right, this is the distance of 10. So that should be my graph roughly. This could be it, 10, because it's going from like 2 to 12 or 13, something like that. It looks a little long. Otherwise, this looks good. It's probably A, actually. No, this is weird. It doesn't stay at point. It's supposed to stay at 0.1 for about 10 seconds. This is weird because it said it starts at 0, so it doesn't start at 0. Violates it there. This one's pretty good. It's just too short, right? Because it says, here, let's read it very carefully. And stays at 0.1 for exactly, then increases to 0.1, then stays at 0.1 for exactly 10 nanoseconds. This is less than 10 nanoseconds. You see this? This is about 8 nanoseconds. This is, actually it looks like a little bit more than 10 nanoseconds, but it's close. So that's why I'm going to go with A. Yeah. Okay. So yeah. That's it. That's it for today's live stream for SAT Math from Scalar Learning. And again, make sure, guys, if you are going to be taking the SAT coming up soon, make sure to check out all my videos. I even have a SAT Math video course that you can find in the description link below. You get a 50% discount if you buy it through my YouTube channel. And make sure to check that out if you want more practice problems. And then I got a whole suite of video explanations for those practice problems, and it's broken down by category, by group. So definitely a good resource. Let's see, I got some questions here. Taking the SAT in April 9th, and I'm really bad at manipulating quadratics and exponents. Okay, if that's how you feel, those are both fairly, the quadratics is even a bigger category than the exponents. So first things first, if you want a free resource, just go to Khan Academy and look at those sections involving the heart of algebra with quadratics and just plow through those over and over. Look at old practice tests, pinpoint and identify those types of problems and keep trying to solve them. I've got a whole bunch of problems on my channel where I go through that. Then if that's still an issue, you can also get my video course, which again, you can find a link in the description below. There's an entire section on manipulating and understanding quadratics, and there's a whole section on exponents as well. Just hammer through those. There's 30 practice problems in each of those sections where you can just go over and over and over, and then watch me solve it. I go through each problem in the course and watch me do that. Then, yes, to Masi, you're very welcome for that. Thanks for watching. Yes, John, you finally made it. Awesome. I'm 500 to 650. That's incredible. That's such a huge improvement. That's amazing to hear. Thank you for telling me that. Can you graph the equation? Yeah, you're welcome, Ayush. Wait, graph the equation ax plus by equals y. Can you give me more info? Ax plus by equals y. Okay, well, first of all, let me isolate it, and I don't even know, because this is weird without not y, I mean b. Wait, can you give me is this the actual equation that you want graphed, ax plus by equals y, or is it something different? And by the way, guys, if you're watching and you're finding this useful, please help me out. Click that like button, would be a huge help for the channel. Okay, ax, got it. Ax plus by equals b. First of all, this is a linear equation. Okay, you can't graph it because we don't know the constant values, but are you sure you don't mean ax plus by equals c? Are you sure that's not what you mean? Or if you can do this, if you can post the image of the actual problem that you're trying to tackle with the actual equation, that might be more helpful. Oh, it's definitely ax plus by equals b. Well, if this is the equation, okay, if this is the equation, this is I can tell you it's linear because both of these have no exponents. I would do this. I would isolate the y. By equals ax. Okay, yeah. So by equals negative ax plus b, and then we're going to divide everything by b. And then you'd get y equals negative abx plus 1. So, oh, really? Wait a minute. I think I have the March SAT. Hold on one second. Let me see if I can find this problem. Okay, give me a second because it's not on my main desktop. It's on my laptop. I just downloaded this. I didn't want to go. I'm planning to make an entire video on the March SAT, but that's okay. And it's going to be during the... Wait, you said... Wait. March 9th, 2018 or 2019 SAT? ...2019. Oh, I don't have that exam. But I am going to get that exam, and I'm going to be going through it. Let me just do a quick search and see if I can find it. All right, hold on. SAT. Okay, let's see if I can get this. QAS Reddit. Okay. There we go. Okay, so question. Which one do you say? 15, and it's question 15, no calc. Got you. All right, question 15, no calculator. Oh, this is awesome. I didn't even know this was out yet. All right. Let me maximize this. You know what? Let me download this. It's probably be better quality. Oh, wow, it's kind of crappy, but it's not too bad. There we go. Oh, shoot. All right, back to this. Let's load up the screenshot here. Okay. Ah, you're right. It is exactly that. I think the way that I did it is actually right. Okay, so in the equation above, A and B. No. It's all good. It's all good. I'm curious about this. Equation of A and B are constants, and A. Okay, so they're saying that A and B are both positive. That's very important. Which of the following could represent the graph of the equation in the xy plane? Here's my equation. So we know it's linear, but all these are linear, so whatever. And then what I did was I basically isolated y, meaning I put it into slope-intercept form. So let me just start over just in case I wrote anything down wrong. Ax plus by equals b, by equals negative ax plus b. Divide everything by b, and I get y equals negative a over bx plus 1, okay? And this is my slope, and this is my y-intercept. Now, it's very important to know that my y-intercept is definitely 1. So B is out, C looks like it's at 1, D looks like it's at 1. Okay, so the y-intercept is good. Then we know that since both A and B are positive, our slope has to be negative. But all these are negative slopes, so that doesn't help much. So then the next thing we know is that B is greater than A, okay? Meaning that it's not an improper fraction. So the slope is going to be something like y equals negative 1 over 2 or something like that. But it couldn't be y equals negative 3 over 2. Okay, so I'm assuming now I can whittle this down further. So I know that the drop, meaning A, is less than the run. So if it were, this is a perfect slope of 1, A is out. Because this is a perfect slope of negative 1. That'd only be if A and B equaled each other, which we know that they don't. Now we know that again, so we can definitely distinguish between these two. So they're saying that A is less than B. So it means that the drop should be the rise should be less than the run. So we should drop less than we run. And this looks like a slope of negative 1 over 2. Drop down by 1 to the right by 2. Drop by 1, right by 2. I'm guessing it's C. And then this one is drop by 2 to the right by 1, meaning the A would have to be 2 and the B would have to be 1. And that doesn't work. The B, as they said, has to be bigger. So C is the answer. Yeah, it's definitely C. All right, does that make sense, John? Like the way that I analyzed it? Because you can't know for sure, right? Like they're all different constants, but that's the best accurate, the best you can do. Yeah, it can't be A because A is a slope of -1. It's really hard to see in the screenshot, but I can tell that it's an exact slope of -1. And if it's -1, it means that A over B has to equal 1. But it can't because of that restriction. That restriction says A and B are not equal. In fact, B is greater than A. So it can't equal 1. It has to be less than 1, basically. It has to be a slope of like 1/2 or 1/3. So that's the gist of it. All right, guys, that is it for today's live stream. Yeah, you're very welcome, and keep checking in. We're going to generally be doing these SAT live streams on Tuesdays, so keep checking in on Tuesdays, and then of course I'm going to do this entire test for you guys and knocking out some other yes, I can review the December 1st, 2018 SAT if I can find it. And if I can't, you can always email me. Email me the PDF if you have it, and I'll be happy to do a live stream and solve it. It's Huzaifa at scalarlearning.com. Just email me there and I'll knock it out. All right, guys, thank you so much. If you like this video, you found it helpful, you're learning from what I'm doing, please click the like button. It really helps me out. Definitely subscribe if you are prepping for an upcoming test, and I will do my best to get you ready and nail that test, knock it out of the park. Most important test, arguably, of your life. So I want to see you do well. Thanks so much for joining, and I'll see you all next time. Take it easy.